en esta charla, presentando en esta charla a Peter Reynolds, agradeciendo para empezar a AADECA, a la Universidad de Palermo y a todos los asistentes que, digamos, la gentileza que tienen de participar, y en especial a Peter Reynolds y a ARC Advisory Group, que gentilmente participan en este evento. Les cuento que Peter es analista de ARC Advisory Group, una firma de investigación de mercado, investigaciones técnicas y asesoría estratégica con sede en Boston, en Estados Unidos. Peter normalmente su tarea es realizar estudios y consultoría para los distintos clientes acerca de la optimización de procesos, la gestión de los rendimientos de los activos, lo que se conoce como analytics, análisis de los datos, y fundamentalmente en todo lo que significa la transformación digital. Tiene más de 28 años de experiencia como profesional experto y surge de la industria del gas y petróleo, y ha publicado numerosos artículos relacionados con esta temática, informes, reportes, y con frecuencia participa en conferencias técnicas de este estilo, como es la de este estilo, en América del Norte, Europa, Asia y Latinoamérica. ARC es la consultora independiente, ARC Advisory Group, una consultora estratégica independiente, más grande que hay en el ámbito de la automatización y la gestión y la integración empresarial. Y bueno, también somos, desde la empresa que dirijo, esta doble función que les decía, representantes, y bueno, estamos orgullosos de que Peter esté con nosotros. Entonces, con esto damos inicio a la conferencia. Peter, please, you can begin your presentation. Y tienen para preguntarnos, tomamos las preguntas, we will have questions at the end, la pueden enviar en cualquier momento por el chat, y al final de la reunión serán contestados por Peter. And then they will send the question by chat, and at the end of the meeting, of your presentation, I will, or Mariana will make the questions to you, and if you don't mind, answer it. Thank you very much, Peter, and gracias a todos nuevamente.
Yeah, thank you, Sergio. Now, before I get started, I think because I am so far away, I'm coming to you live from New Brunswick, Canada, and if you're not familiar with the geography of Canada, I'm on the far east coast. So I'm just going to shut my video off, and I'll turn my video on again at the end of the presentation during the live Q&A. And I have a relatively short presentation that I'd like to share with you today. If you just give me just a moment, I'll get that available for you to see. So one thing we've decided to do is we actually felt as though we would do translations live during the Microsoft tools. So I'm going to do my best to speak slow to make sure you understand my presentation. But if you notice at the bottom, you'll see some hopefully very accurate translations of my English. So the purpose of this presentation is really about digital transformation. The group at the Association of Argentina Control and Automation, they really wanted me to present research, what's happening with the current state of digital transformation, and what's happening in the future state. Where is digital transformation going? Just a little bit about me, and thank you, Sergio, for that wonderful introduction. So I'm an analyst and a consultant, and I've spent my entire career, nearly 20 years, in the downstream manufacturing, IT, and automation in the refining oil and gas industry. And I've spent nearly 10 years as an analyst and consultant. And I work for a wonderful company based out of Boston, United States. And this company focuses exclusively on operational technology and automation. It's a very unique company. We tend to hire analysts and consultants that come from the industry, such as myself. And we have a global presence in United States, Canada, Germany, France, Japan, China, India, and offices in Brazil and Argentina and Middle East. And our company was formed in 1980s. Here's just a sample of some of the companies that we work with. And as an analyst, I work with the supplier community, and these are the companies listed at the bottom of the slide. You know, companies such as Rockwell Automation and Siemens and Honeywell or Oracle. The suppliers that are part of our ecosystem, they inform us as to what's happening in their roadmaps, and likewise, we inform the suppliers of the best practices and the needs by industry. And some of those needs come from the companies that are listed at the top. Many of these are oil and gas or chemical or petrochemical or pharmaceutical or other industrial companies, but we solely on the operational technology stack, and other companies like Gardner do a wonderful job at tracking the IT space. So first of all, why is this important? Why are we talking about digital transformation? Now, the fact is that 2 years ago, I presented at this very same conference, and I was on the big screen. It was broadcast over Facebook Live, and there was an audience full of people together in one spot. So today, we're doing a similar presentation with a similar theme. We're all doing this from our offices and our homes because we can't be together. So I'd like to talk a little bit about the status quo for industrial companies. So if you're associated with an industrial company as a supplier, as a technology service provider, an original equipment manufacturer, or you're an asset owner or owner operator, there are going to be some important things for you to consider with respect to digital transformation. And our research would tell us that the status quo is not an option. There is a tremendous push to change, and all of these factors that I'm showing you are impacting change. One of those is sustainability. And the sustainability are factors that involve people and development and profit, and mixing that with environmental concerns of land and water use and carbon in our planet. So sustainability has changed the landscape on the investment for digital from the customer demand side, whereas customers or people are making different decisions with the products that they purchase. And those products need to be sustainable or circular in nature and don't end up in landfills. The investor community, likewise, has given strict instructions to manufacturing companies to improve their focus and efforts in sustainability mandates. And one company that owns nearly 10% of industrial assets worldwide through investments is a company called BlackRock. BlackRock will no longer invest in companies that do not have sustainability at the front of their portfolio. Nearly every company that we speak with and we consult has digital and sustainability top of minds for board of directors. And in fact, when the investment community asked the board of directors about their progress, they ask about the initiatives for sustainability, and they ask about their digital strategy. Now, along came COVID-19, and made us to a point where we couldn't be within 6 feet or 2 meters from each other. That impacted how we meet in the office. It impacted how operators conduct their business in plants, or how maintenance people and service providers support equipment. Not only has COVID-19 impacted our ability to support and maintain manufacturing facilities, it's impacted the supply chains and the very economics that supports a lot of these industries. So we turn to things like energy and transition and demand destruction. If you're associated with the oil industry in Argentina, you'll know that there's tremendous demand destruction, and many refineries have been forced to either idle or reduce output, or the oil projects have been temporarily halted. So this has changed quite a bit on the supply chain side of industry. So why digital transformation? And many of you are probably selling digital transformation or digital strategies within your company. But these are the types of questions that are top of mind for your executives. Your executives are asking, should we digitally enhance and rethink our operating models? Right? Should the operating models consider a different way to work to ultimately make people more effective, or to help change work processes that are more efficient? Executives also want to know about peers and how peers use digital technology as a competitive advantage. And more importantly, there's an even stronger recognition that domain expertise and knowledge of manufacturing is highly valued. And the executives realize that there are some disruptive changes coming in industry, and the most important thing is to ready their workforce. So what's happening on the technology front? And I just want to give you a view of something that's a little bit removed from automation and the industrial facilities. But if you think about technology in general, I'm going to give you some examples of how this is impacting the plant. But if you look at the vertical axis, we're mapping the disruptive impact of a technology. If you look at the horizontal axis, left to right, this is time. And we've broken this into 3 phases. There's usually phase 1 of some technology change, phase 2, creation of application or applications, and finally, phase 3, a business transformation through digital. So starting at the left, let's think about disruptive technologies emerge, and there's some miniaturization, or in the case of mobile phones, this was in network communications at the semiconductor. As part of that phase, through miniaturization, there was improvements in network communications and what we call combinatory effects that stimulate future development, usually by the combination of several partners. Now, if you think about phase 2, we started off, and let's go back with the mobile phone nearly 15 or 20 years ago, and there's a picture of a flip phone, right? It was a feature phone based on, much smaller miniaturization enabled this phone, larger screens, but it was primarily built for text messaging and voice communications. And then a paradigm shift happens when Apple developed a smartphone. And so the smartphone, the computing capability is so high, people view this as a computer in their pocket. We've gone from technology emergence and combinatory effects to a paradigm shift with an application. And what this application does is this is how companies can take this phase 3 approach and think about things like WhatsApp or Uber disrupting the way people get to pay for taxis, or Netflix or Airbnb. So these are all companies that have experienced a digital transformation and disrupted an industry because of technology disruption. If you think about what's happening in the cloud, we started with private clouds and servers installed in our data centers. Right? And there was some reduction and simplification for cost management, and companies moved to application service provider and hosting, right? So that was done for growth, usually by acquisitions or obsolescence, or sometimes companies had a burning platform. And then again, a paradigm shift happens with companies like Microsoft Azure or Amazon Web Services now building cloud, secure clouds at such a scale that companies can't refuse. So even industry and manufacturing see public cloud, Microsoft Azure, and Amazon Web Services as a tremendous enabler for digital transformation to do things like rapidly scale connectivity solutions or simulation or mobility or augmented reality. Because the reality is for most of manufacturing companies, it's been very slow and they have not been agile to take advantage of these technologies to answer those questions that I posted earlier that your executives are looking for. So to put it in perspective, and I know this is a bit of an education on digital transformation, but we think there's a lot of confusion in industry. We see three different terms, each with vastly different approaches. And we see these as digitization, which is essentially creating digital versions of previous analog or physical items. This could be moving from paper inspections to using a tablet, or from an analog pressure transmitter to a digital pressure transmitter. It's a first step. It's considered basic infrastructure, and it's usually to increase, maintenance, some function, relatively few stakeholders. Digitalization, on the other hand, is the use of digital technologies and methods needed to change a business or a process. Again, it's incremental change. It's usually project-centric, but it focuses on changing the way we work with usually more stakeholders. Now, digital transformation is something different. I think most companies are working on digitization and digitalization, but few companies are really successful at digital transformation. And I'm going to talk about why in this presentation. Now, digital transformation is something very broad. Scaled up digitalization usually involves new business models. And for those of you that are in the oil industry, you may have some familiarity with Shell. And Shell has gone public and stated by 2025, Shell will derive more revenues from the sales of coffee at their retail stations than they will the sales of fuel. That's a transformative business strategy that in Shell's case is going to be driven by digital and the customer experience. It's normally invasive change. There's normally a big operational excellence or an improvement program. It involves people's teams, sites, standards, agile centers of excellence, and there's normally multiple stakeholders. So as you're working in your company, and you're selling change, or you're hiring a contractor, you need to really think about what you're asking the contractor to do. Because we do think that digital transformation is a word that's far too often used. The others are just as important in some cases, and sometimes digitization and digitalization are foundational. Now, what are the technologies involved? So as an analyst, we get exposed to a lot of different suppliers and companies. We hear what companies are doing and how they're making improvements. So the 8 technologies I have on the screen here, the ones that we see most often in the process industries. So again, digital transformation in the process manufacturing is really a transformation about people and what they do. And it usually involves some type of connectivity, especially during COVID. Everybody is working remote. And if you're wondering what people are doing in the Middle East or in Europe or America or China right now, they are at their homes or their offices. They're on different shifts. There has been a rush in the past 6 months to get connectivity through remote services so people can work from wherever they are. This is a big change. We've seen cloud computing as a great enabler to rapidly scale up applications at very low cost and high security. Things like robotics and drones, of course, we don't have the ability to build staging and do massive inspections and execute all this cost. So things that were, they had business cases or they were not top of mind of executives and directors and managers. Things like these disruptive technologies are of greater interest because of COVID. Same for additive manufacturing and the ability to 3D print titanium metals to support supply chain. So you're not waiting on suppliers because, of course, COVID-19 has impacted supply chains and the ability to get materials to manufacturing. And of course, all this focus on connectivity, there is a greater need for more sensors and more data and more networks. So 5G is coming on very, very strong at the level and a layer and a great interest. Cybersecurity, certainly another enabler. And in this presentation, I'm going to talk a little bit in detail about why artificial intelligence and machine learning are really disrupting the process industries. So if you think about, well, what does this mean for a country, or what does it mean for, what does it mean for an organization? If you think about how we've started, right? We started off with mechanization, basic control and monitoring, and IT enablement. And what does all that mean, right? Those were really building blocks for us to get something which is more computer, cyber, artificial intelligence. There are a number of studies, and I'm using data here from the World Economics, and these are real percent improvements in gross domestic product. And generally, productivity from the steam engine back in the 1800s was about 0.3%. We created light for factories, and there was another small improvement through electrification in the 1890s. And then through productivity growth through DCS and automation era in the eras, again, it was another small improvement. It was an important improvement. And then we entered the IT enablement era, and we got more growth from client server in IT and service-oriented architecture back through the 2000s. But most companies would concur the area that's of most interest to them is the area of artificial intelligence and machine learning to augment and help people with their decisions. So now just a little bit on the challenges, because let's face it, those of you that are selling change or involved in projects in your company, whether you're a supplier or service provider, there are some challenges in taking artificial intelligence planned. So this is a series of statements and some data that we've been collecting from about 2016. In 2016, the term industrial Internet of Things was born, and that was really a premise for companies to consider, transformational change using digital. So what we found from our surveys, and we do a lot of benchmarking surveys of organizations, we find that only 5 to 8% of companies believe they're ready, right? So this is one particular survey, 157 process manufacturers find there are barriers in organizational accountability and confusion, culture and employee mismatch, change management. All of these impede digital transformation. However, on the other side, 85% of manufacturers believe they're ready for advanced technology. So artificial intelligence is a high priority. Pilot projects are common. I just have some examples of what we hear from our executives. One such executive, this is a U.S. pulp and paper innovation leader. 10 billion. This is the opportunity for our company through digital transformation. We have become more agile. How can we become more agile and scale up deployment? We have become distracted by too many proofs of concepts. Our operators are not seeing benefits from predictive maintenance solutions, right? We want to be positioned to adopt new technology without compromising security using data already gathered, right? There's a tremendous installed base of automation, DCS control systems, programmable logic controllers that have been in place since the 1980s. There's a realization that there's much data that has not been leveraged. And then finally, this is a global chemicals business transformation leader spoke to me and she said, Peter, the gray space is broken processes where accountability exists between plant and information technology organizations, and this is a huge barrier going forward. So a little bit about the data, and so I have a background in downstream refining. I worked my whole career associated with distributed control systems and programmable logic controllers and sensors and instrumentation. That's really where I got my start before I came an analyst and a consultant. And generally, my feeling in the research that I have done shows that the oil industry is not that unique from pharmaceutical or petrochemical or other process industries. They tend to not use the data that's already collected, and many companies have a process historian for that. There's a tremendous amount erosion of talent that's an issue. So companies are looking to machine learning to identify patterns in big data people cannot. And so just a little bit on machine learning. So if you're not familiar with machine learning and why it's important that it's entering the process industries, so computer science, so machine learning is evolving from the form, it's a study of pattern recognition and computational learning and artificial intelligence. So the goal is to have a machine mimic the mind and behavior, which includes abstract thinking and learning from past experience. So machine learning closely is related to data mining and statistics. And ultimately, machine learning is a form of programming which is not explicit programming, which is a key differentiator in the market. So there's a couple of different types. You're teaching computers to make predictions using what's called supervised and unsupervised learning. And I'll just quickly go through some examples of machine learning applications. I know these are not process applications, but you'll identify these as things you may use in your life, such as if you use Siri on your phone, machine learning underpins voice recognition on mobile phones. Netflix has machine learning built in to make recommendations for the next show you watch because of algorithms that look at clustering of data. Credit card fraud detection, ultimately, the algorithms look at consumer purchasing and spend analysis and apply risk to understand whether or not your credit card has been violated or it has been used by someone else and they need to lock it down and prevent more fraud. And here's another example. And this is kind of a funny story. And so in machine learning, first of all, machine learning is not new. So in 2009, there's a group called ImageNet. And this ImageNet project delivered a database of 15 million images across 22,000 classes of objects. And things were organized by everyday English words. By the way, your average plant has 22,000 classes of objects, and it would be 15 million data points associated with those points, right? So both in quantity and quality, this was an unprecedented scale back in 2009. So in all the cases, there were more than 62,000 cats of all kinds of looks and poses. So this group, ImageNet, used something called Amazon Mechanical Turk to capture 15 million images, 22,000 categories, and use big data and machine learning algorithms to train the computer. So what does that really mean? So just an example. So supervised learning, and this is a fundamental of computer science. It's supervised learning is identifying a picture and having a human say this is a cat. And the example of Mechanical Turk is you can sign up through Amazon at the time and you'd be able to get royalties for pressing buttons and identifying pictures. And you would say, well, this isn't a cat. This is a cat. This is a cat. This isn't a cat. So this is because I can look at the picture as a human and I can identify what it is and it isn't. This is called supervised learning. Then unsupervised learning is once you start to train those algorithms, computers actually get really good at identifying features and make associations on their own. So what the computer is able to do is actually associate pictures with what they are based on the algorithms in supervised and unsupervised learning. And now this is 2009, and this is a funny part of the presentation. This is real data. This actually happened. And so the ImageNet actually, the point was to identify that machine learning was not perfect, and the picture on the left-hand side got confused with an alligator and a duck, and it called it an animal. And at the picture on the top right, the computer said it's a man riding a horse down a street next to a building. So the computer wasn't smart enough to determine that was a statue. And the one on the bottom right with the baby and the toothbrush, let's face it, the computer had never been trained what a toothbrush was. So it's not perfect, and many companies refer to this as probabilistic outcomes. Now, what's happening in the process industries is machine learning starting to get really good at seeing patterns using things like autonomous agents. And if you're in process manufacturing, you may have used a process historian or looked at trend data. So I have an example here, which is pump cavitation. And pump cavitation is actually really difficult to find out. Pump cavitation can ruin the internals of the pump. And the current technologies at the automation space are really not great at detecting this. As a matter of fact, oftentimes the operators that are outside need to determine cavitation by looking or putting their hand on the pump and listening. So HMI and operator screens and alarms are not great at detecting this. The machine learning, this is an application of machine learning. Now, ultimately, you're not going to want to apply machine learning to every piece of asset that you might have at your plant. So we have a couple of different technology descriptions here. Well, one is performance, and performance analytics is typical for 2000 to 2015. Business intelligence is a performance analytic, and it's really good for determining what happens and why. And if you think about 2015 and beyond, when 2015 was about the time when machine learning started to enter the process industries, we call it predictive and prescriptive analytics. And predictive analytics is about using unstructured data, big data, machine learning combined with business rules. Usually machine learning is delivered in the form of an application, or internally you have a sandbox environment in order to build this yourself. Companies recognize that machine learning is important for proactive decisions and well-planned approaches, usually in weeks or months. So this is about identifying problems you didn't know you had versus reacting. Now, I want to share with you a couple of different use cases for machine learning and AI, because we think it's one of the pillars of digital transformation. Now, this is some data that we have from I think it's from the U.S. I want to make sure I get this right here. Aaron Broberg, right? So this is a assistant manager of engineering service from Adel Precision Products Corporation. So these are used by the military, and a lot of the studies from the military, these studies are probably 10, 20 years old. 82% of assets fail or have a random failure pattern. Right, so you can see here the age-related failures on the top, the random failures on the bottom. You find that the age-related failures is about 18%. The random failures is 82. Now, when you apply these principles of random failure to the process industries, they actually find that the 82%, a large portion of the failures are not so random. are more due to poor maintenance and operation practices. And as an example or use case, many of you might be familiar with the probability of failure curve, and essentially it's age asset performance on one side and time on the other. If you think where the green point on the left, that's the point where failure begins to occur, not necessarily due to age. And at some time frequency, the point P that's yellow, that's the point where an asset begins to fail, and that's usually the point where maintenance groups are brought in to do oil analysis, vibration analysis, thermography. There might be some vibration, noise, or smoke, or things like that. But the strategy for maintenance is to really extend the probability of failure interval as far to the left as possible through the most economical means, because ultimately at the failure point, the red F on the right-hand side is not an area that's good for operating environment. So in terms of a use case and application for machine learning, this is one huge area, because operators and maintenance people are not good at collecting data from multiple data points and using this data to perform an assessment of when things are going to fail. So if you think about expanding the probability of failure curve, one thing we find is this term called process abuse, and you may use this in your industry. What happens in a refinery or a chemical plant or a batch process is a lot of things that are unknown to the reliability specialists that are maximizing the PF interval. There's things like incorrect set point by operator, incorrect information, wrong procedure, exceeded operating envelope, or product quality. These are all things that are happening, and historian systems and other condition-based monitoring systems are not good at dealing with multiple data points to do this. So back to the ImageNet in 2009, the group that wanted to identify 60,000 images of cats, that same technology is being applied to the process industries, usually through applications or sandbox environments, to figure out, help operators understand what's going to happen and ultimately what the operator can do about it to avoid a failure. Now, I want to go over just a few more use cases, and I know we're getting close to the top of the hour. One of the things we do at ARC is we do spend a lot of time helping our clients understand digital transformation through readiness assessments and surveys, and we help teams sell digital transformation internally. And this is a use case presented by Saudi Aramco, one of the world's largest oil companies. This was presented in 2019, the ARC Advisory Group Orlando Forum in February. And if you see what Saudi Aramco is doing, is they're using technologies like drones to detect leaks, and they're using other algorithms and applications to detect shortages of material. And they're monitoring their assets in real time from a remote location and using models to help predict what's happening in the facilities. So these applications ultimately are able of creating alerts and suggesting actions, generating preventative maintenance work orders, and dispatching technicians. So there's a lot of different technologies here that are helping Saudi Aramco reduce costs. Here's another one where this was a rail company that had an issue with getting employees from point A to point B. Their commuter trains had bad wheels, and this was a major safety concern for this client. Of course, bad wheels means commuter rails are out of service and potentially life safety issues. So what happened in this case is this company, they looked at all the operational data that was available. They added available customer data, including the passenger counts, and they applied this machine learning using unstructured data mechanisms, and essentially they were not able to identify failures with conventional means. They actually correlated wheel failures between toilet flushes and wheel bearing degradations. So this is really an example of big data. And back to the spectrum of analytical tools, this is an example of conventional performance or business analysis or condition monitoring tools would not work to solve the problem for this rail company. This is another one that saved. This is CSX. This is one of my clients. They saved about $1 million a day by applying machine learning and other methods to detect engines not loading 100 days in advance, or low viscosity 90 days in advance, or a low viscosity again at 108-day intervals, to ultimately prevent analysts from or engines from shutting down. So the combined benefit for this company, CSX, was a combined lead time failure of 570 days. Is another example with processing corrosion is a significant operating risk. In the case of this company, they were saving about $300 million in equipment damage and costly annual repairs and the evaluation they had was very complex and error prone. So they essentially provided, 200 plus types of crude. They combine, silo data with knowledge of the plant and knowledge of the crude assay. And they created a high-level decision flow by pulling in structured and unstructured data. So ultimately, they created a knowledge map using advanced analytics that allowed them to search crude type and mitigate any risks associated with failure of due to corrosion or pipe leaks. And lastly, I just want to present just one more slide on the use cases. So essentially, there's no limit to where advanced analytics and some of these digital transformation technologies are applied. We see it in reducing process variability. We see it in improving quality. We see it in improving asset health and unplanned downtime, and ultimately incident prediction. So there's not just a financial benefit to digital transformation. There's a tremendous safety benefit, which, going back to the challenges that we're faced with today with COVID-19 and sustainability, these types of projects help companies meet sustainability directives and help people do a better job during the coronavirus. So I'd really like to just leave this final point to you that it is complex to implement digital transformation, but there's no end to where you can start. So what I'd like to do is just really hopefully you've had some questions on your mind and you've typed them into the chat box, and I'll be able to take a look at those and hopefully answer those for you. I'm just going to put my video back on because I've now stopped sharing. And let's see if I can find any questions. Maybe Sergio, can you help me find?
Yes, Peter, there are some questions. Mariana will translate it for you, those for Spanish and for English, okay?
Okay.
Okay, we are now in the question and answer area. So please, there is Germán Nicola, who says that many of his clients are interested in digital transformation. They have many fears. They don't want their data in the cloud, in the web, and they do not have the staff trained enough. So they see many solutions, many offer solutions, but they seem very different and varied. How can he start to discuss issues with his client?
Well, that's an interesting one. But so you mentioned the cloud and data, and in my presentation I said that cloud was a great enabler. I find it's an awareness issue. some of the areas that have slowed progress is organizational strife or organizational disconnects between information technology and operational technology. The most secure, most confidential email, or the most confidential information in a company is company email. And the company email has already moved to the cloud. Usually what happens is when companies want to accelerate some type of application, and first of all, I'll say that distributed control systems and real-time information or programmable logic controllers are not moving to the cloud at any time soon. But it's the data that can be harvested from these systems to improve decision makings. So I guess my recommendation is to have a chat with Microsoft or Amazon Web Services about the security that they offer. And most companies, once they've evaluated the security offering from either of those two companies, there's no way that their internal staff can compete with the capability in that area of those two cloud providers.
Peter, perhaps you can see the chat. The people is asking in English. If you can see the chat, you can read it and answer it if you want.
Was that for me, Sergio?
Yes, Peter. There are questions in English in the chat box. If you can read it, if not, we will read it for you.
I found it. Thank you. This is my first time using Blackboard, so you have to forgive me. So here's another question from Lewis. It says, what opinion do you have related to left? What opinion do you have related to left in industrial control to AI machine learning and regarding the risk because of loss of process control? So I think, I think it's really important. We're putting machine learning and artificial intelligence in electric cars, right? But we're not, so that exists. Some of it exists in the cloud, but we're not taking the engine out of the car, right? Or same with the aerospace industry is not removing, the need for real-time processing at source. So I think the same goes for the process industries or even any industry. We don't see companies moving real-time control and safety processing, which is normally done by a distributed control system or a programmable logic controller. We don't see that moving from on-premise. We see that the deployment being done on site. So let me see here. I'll look at. There's another question here from Andre. So, what's the gap that ARC see in industry to apply machine learning for maintenance when companies don't have data collection or data historization? So I think that's really important. The one thing I'll point out is the CSX example, and I have more details I can certainly follow up with on how CSX did machine learning, because they didn't have a lot of sensors to perform oil analysis. I think that what happened with CSX is they set up a process in place to go and collect it manually in the beginning. And since they had a number of saves, and in the case of CSX, they saved $1 million per locomotive. Because what was happening is they were getting cooling water leaking into the oil. So that's why they were doing oil analysis. But since then, they have applied some sensors to do it manually. So I would say that there's still machine learning usually implicates some work process. There's usually some improvement. Companies are using the benefits, savings from the technology to fund sensors and the improvements that they need.
Peter, there is a question, and this must be the last one. I'm sorry to the people. What we will do, we will send the questions to Peter, and he will answer it if you can. please, Pete, and we will send it to you from AADECA. There is one question at the beginning of the chat from Diego Alvarez. Can you read it? 5 minutes? No, 3 minutes. I have, because 1 p.m. Other activities began. Empiezan los talleres a los que estamos invitados y se debe cortar la transmisión. Los invito a entrar al área de talleres a las 13 y incluirse entre varios talleres de hoy da Siemens, micromecánica, Cruzair y nosotros y SBS Consultores. Please, Pete, Diego Álvarez, you read it?
So Sergio, which question was the one you wanted me to answer?
When I write it in the chat box, what impacts, cannibalizations, or synergies do you think may exist?
Okay, so the question is from Diego, and it says, what impacts, cannibalizations, or synergies do you think may exist in the near future in the advanced process control business in relation to the new IIoT platforms that are disruptively modifying the classic structure of the ISA 95 automation period, adopting big data or artificial intelligence? So advanced process control, I produce a global market study for ARC on the advanced process control and optimization market, so I'm familiar with what's happening there. So I think that there is a disruption taking place, or synergies, especially in advanced process control, because optimization is incredibly challenging, and there are a shortage of engineers to not only deploy the models, to keep models up to date. So first of all, I'll say that advanced process control and optimization is extremely important for margin improvement, or to help keep companies running steady, which impacts improvements in operational safety. But the real synergy, or the disruption that's happening with respect to advanced process control, is the ability for machine learning algorithms to harvest data and build better models. So what took weeks and months to build a single controller is now done in a matter of days through machine learning modeling. So empirical modeling, or first principles modeling, is not going away. But machine learning is a toolkit that can drastically expand the applications and the number of applications, whereas advanced process control can be applied. And with respect to the ISA 95 automation pyramid, I think that I look at the automation period as getting a little bit bigger up in the enterprise. And what I mean by that is if you look at manufacturing operations, MOM, and I know ISA has got tremendous work they're doing with ISA 95 today. I look at the enterprise as expanding their ability to reach down and grab real-time data and do analytics. So you still need MOM, manufacturing operations management, or MES application in that space. It doesn't have to happen at level 3 now. It can happen quite well at level 4 or level 5 at the enterprise.
Ok, lamentablemente tenemos que cortar, falta 1 minuto para las 13, we have to end, Peter. We appreciate your presentation, it was very useful for us, and I think for the people that are in this area, in this presentation. Quiero agradecerles a todos en nombre de AADECA vuestra presencia. Las preguntas que quedaron sin contestar serán enviadas a Peter y les serán devueltas, digamos, las respuestas. Peter, thank you very much. Gente, muchas gracias. Los invitamos a las 13. Están los talleres. Entren en la otra conexión. Hay otra página y, digamos, hay otra forma de ingreso y deben entrar, si quieren asistir, a talleres en ese ingreso. Ahí Ariel está poniendo la forma de ingresar a los talleres. Muchísimas gracias y que estén muy bien. Thank you very much, Peter. We will talk later. I have to go to another presentation now.
Okay. Have a good day, everyone. Be safe.
Thank you very much.